Assalamu alaikum. Welcome to Civil Ideas. So today we'll discuss about the barbending schedule that normally followed in the construction process. So this is normally prepared for the schedule of the bars, reinforcement bars that is used in the concrete, RCC concrete. So this is the calculation on the weight of the concrete, with how much reinforcement used in the construction and each elements. Okay, so now I will discuss generally the format and how it prepares in this video. So let's start. So first you can see here in the bottom in these steps, you can see here this is the foundation, and this is the blend beam, and then columns of the blend beam, and then bar bending of columns. Okay, so I have put it in the sequence, so you have to uh, do this in a sequence form. Bar bending of the ground floor and slab beams, slabs, ground floor slab. You can see here this is the ground floor beams. Okay, so you have to prepare it for each elements, so you have not mix up, and the clients and the consultant can uh, read it easily. Okay, this is a parapet wall. So now we will discuss each of these in detail. So first you can see here this is the foundation. So first we will discuss the format. So generally this is the serial numbers. You can see here serial numbers, and this is the description of each elements, and this is the bar dia number 4 and number of elements. Okay, if there is same elements, the bars use and each element the same, so then you have to just multiply that number of elements. Okay, and member lengths, widths. Okay, and this is the center to center spacing, number of bars, total length, cut length, total length. Okay, total number of bars, and this is the total number of total length. Okay, this is the unit weight. Okay, and here we have fixed the formula. I will show you now, and this is total weight in kg. Okay, and this is the shapes of the rebars. Okay, now we will discuss and the format for our same for each of elements. So now this is the F1 grade, D5, E5, and 9.9 feet. So this is the dimension of the footing. Now I will show you this fitting. Okay, so you can see here this is the drawings. So these are the footings. You can see here this is the dimensions, 4.4.75 in this direction. You can see here the total length will become 4, and this is will be in this another direction. So you have to just uh, now I will show you actually. So okay, I will show you the grade. Okay, and in other drawings, so where the grades are mentioned, I will show you. You can in this drawing you can see here there's, so you can see here this is the grades. Okay, A, B, C, and you can see here I will take for you. So these are the grades. Okay, so you have to write the grades, like I write the F grade. So here's the F grade. Okay, and then also there's another grades on the other side. You may have seen at the bottom side, you can see here this is the 1 2 3, and this direction is the A B C D. Okay, so you have to if you point out in this column of this footing, this one, then you have to write the B grade. Okay, and which one is 2, b2. Okay, so this is the b2 column. Okay, and if there is on the same line there is another one, then also there's the d2. Okay, this is the d2. Okay, and the same. Now we will go to the Excel sheet. Okay, so you can see here, this is the so this is two element because these footings on the two sides are same. Okay, and this is the member length and width. Okay, so 9.5 is the total length, and you have to show you. So this is the footing. Okay, and this is the full length 9.5. You can see here. So you have to minus the clear cover, maybe 1.5, 1.5, 1.5. So you convert it into inches, so it will look like this. Okay, I will adjust it so that you can understand it easily. Okay, now, and the other thing, center to center spacing, it is mentioned in the other drawing. Okay, so center to center spacing, the detailed drawing of footing may be there. Okay, so here may be mentioned in this drawing, you can see here. So here they have the typical footing drawing, and here is the detail. This is the plan and this is the cross section. Okay, this is the plan and this is the cross section, so you have to read these detail. Okay, now you have to look for the dimension here. Okay, dimension A and dimension B. Okay, so this is, you can see here, f1 footing 1, footing 2, footing 3, like this one. You can see here 1, footing 2. So there may be 5 footing of type footing 1. There may be 2 types, 2 number of footings of footing 2. There may be 3. So it depends on the project, but you have to need the scale need to, you have to read these drawings and cross sections. Okay, and there is another detail. You can see here number 4 is the rate 12 inches. So this is the detail. Okay, now center to center spacing, like you can see here, this is the center to center spacing. Okay, this one, so you can read these. Okay, now, and the other one is the number of bars. So how number of bars, you have to put the formulas. Okay, so member length, total member length divided by the spacing. Okay, divided by the spacing of 1 bars, total length divided by the, divided by the each spacing. Okay, so you will find the number of bars. Okay, and total number of bars, how much elements are there? 2. So you have to multiply this with 2, then it will be converted into how much elements. Okay, so cut length, you have to this is the member length. And what is the cut length? We have plus 0.5, 6 inches. So you have to 6 inches, like this is the bar, and you have to 6 inches this and 6 inches this, because you may have seen this, the bar is cut like this. So this is 0.5 and this is 0.5. Okay, so you have to add up on these things. Okay, now you can also read these from the plan also, or maybe from cross section. And this is the cut length. Okay, and this is the total length. So total length will become total number of bars we have find it here, and total cut length, then it will be shown like this. And this is the number 4 bar. So you have to put the formulas. This is the d square d square divided by 2.25. We have divided this square divided by 24. This is the formula. And for to convert pound for pound per square inches, so now you have to convert it into the pound kg. So 2.205 divided by 2.205, so it will be converted into kg. Okay, now you can see here, this is the unit weight of, and this is the total weight in kg. It will become like this. Okay, now so this is the unit weight. You can see here, e square divided by 24. Okay, I will write the formula, d square divided by 24, and pound per feet. Okay, so this is per feet weight of the bar. Okay, now we will to convert it into the kg, so 2.205, this is the convert into to kg. Okay, so this is the formula, number 4 bars, so 4 multiply 4, this why, and the total weight is in kg will become the total total length, and then the unit width multiplied by unit width, so it will become the total width. Okay, this is the shape of the bar. You can add these things. Okay, and the rest are same. Again, for the another direction, you can see here. You see, this is for the other direction. Sorry. So this is the x direction, this is the y direction, and the rest are typical, all these footing. If there is some changes, then you can read it, but you have to just study for one footing, then the rest are same. Okay, and some footing there may be only steel bars at the bottom side. Okay, like this. So you have to look for this footing according to details. This is for the footing. Generally, I'll not go to into detail because it will be a longer video. So this is the F grade, and this is the grade B5 and B6. I think you have understand these things. 8.5, and this is the dimension of the footing, x direction, y direction. Okay, now we'll go to the plane beams. Okay, and I think I don't have the drawings and plane beam now, but they have a typical. Okay, this you can see here is the same, the rest format are same. So this is the PB for plane beam, and this is the grade AH1. Okay, now I will show you the drawing if I have. So this is the so you have to read these things. Okay, like for the first we have to find the horizontal beams, so you have to like AH1. Okay, so this is the A, this is the A, and this is the H. Okay, and which one is this, and this is the one. Okay, so A, H, and the one grade. So this beam. Okay, this beam I have write the allocation of this beam. So this beam you have to write it into A2, 8 from A to H, and the one grade on the other direction. Okay, so you have to mention these things while doing calculating sheets. Okay, so now this is the number 6 parts, number of elements, and this is the 2 number of elements you can see here. So there may be I think I have put one this beam and the other is this beam, so that's why I will write it 2. Okay, now This is the cut length. Okay, number of bars. Okay, number of bars in each beam. Okay, so now this detail you have to look into the on this one. Okay, how to find the number of bars? You have to schedule of plane beams. Okay, so this is the plane beams. Now plane beams 9 by 18 is the cross section, and this is type 1. So type 1 you have to read the rest dimension from here. This is the type 1. Okay, so here this is the type 1, and this is the plan and section of uh, 1 you can see here. So you have to detail these things, okay, accordingly. And the bottom reinforcement, and this is the extra reinforcement, this is the top reinforcement. Okay, and this is the sections. These are the sections you have to study at and detail um, location of the, and this is the NA. So you have to look for the direction, like this is the B, this is the location of the this is the sorry, B plus, this is the B is throughout beams, and the D is the extra bars. You have to look for how much D. Okay, so you have to check the extra reinforcement. So B is you can see here the B is 1 number 6 bar, and what is C, like B plus C here, right? So B plus C 2 number 6. So one is extra bar, you can see here. So this B plus C, you can see here, B is 1 number extra bar and C is 2. So now here is also C. So only these 2 number of 6 bars will go throughout, but on the 1 number of 6 number of bars at B will also be at the ends. And the bottom there is A. So you can see here A 3 number 6 bars. Okay, that will be easy once you have read the drawing. 3 bars at the bottom, and like bottom main bars, top long bars, two number of bars you have seen in the drawings, the top and the throat bars, the 2 bars, extra end bars. Okay, so number of elements 4. Why? Because there are 2 beams, and for 2 beams you may have seen that like this is these 2 beams, so the end will be 1, 2, 3 and 4. Okay, so you have to detail like this, and the rest things are same. This is number 6 bar, so you have to put the formula like unit weight 6 number 6 divided by 24, and there is another also formula d square by 533 for feet, and also the d square by 162. This is for the meter and metric system. Okay, so you have to follow any formula suitable for the unit weight. Okay, so then the rest are same. You have to just mention the length and the grade of the beam. Okay, and you have to point out this beam, then you have to also this grade and this grade, and the other direction this grade. Okay, so these are the same thing. Okay, now you can see here plane beam column. So this is for column. So column you can see here grade 1 C number 5. There is a lot of number of columns. A number 5. I will show you if there is column drawing I have. Okay, maybe here. So this is the column. Okay, you can see here C1, C2, C3. So you have to like this is C1, this is C1, 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 and this area. Okay, like in this area this is C1. So you have to put each location like B into 1, into D into 1, and D into this is 2. You have to put this location and this location with respect to this for each column. Okay, so like this is the column, so you have to put also this location and this grade. Both grade you have to mention add here, like I mentioned, add for each column. Okay, so these are for sample for the beams. You can see here. So the rest will be same. This is the shape. You can add these shapes from here, like insert shapes. So these are the shapes. You can make it any type of shape from here, and also add up clear actual pictures. So main ties, this is the ties. You can see here main ties number 3, there are 4 inches. So you have to read it from another drawing. If I check it, so I will show you address. Okay, and this one you can see here. I think this is the rebar. Okay, this one. You have to read this it for column rebars. This is the longitudinal rebars. Okay, this is the lap, and this is the mention this spacing of these stirrups. Okay, reinforcement, and this is the stirrups you can see here. So it will be gone throughout, but here there are 4 inches. Okay, measure it here. Okay, so now we'll go to the next one. So the rest are same, and the add, you have to add all of these total number of kgs, and then tons divided by 1000. You have to add for the entrance. And same thing for slabs. Okay, for slabs, so this is the shape of the slabs and the extra bars. Okay, so I've not gone into much detail. This is the full barbending schedule for two-story building structure from foundation to top level. This is the parapet wall. You have to draw. This is the parapet wall full dimension. You can see here full building, and you have to just read from the drawings this dimension and draw these things. Okay, and this is for the columns, first floor columns. Once you have made a bar bending for ground floor, then the rest will be same for the other floors. Not much difficult once you have done for any one project. So if you have any question, you can comment. I will make another detailed video. Thank you. See you in the next video.